Hey students, this is lesson 8.1. We're going to learn how to use graphs and tables to solve equations. Today we're going to do lesson 8.1.1, which is how to use graphs. I'm going to be using my graphing calculator, so if you have one handy, that'd be awesome. Just kind of a word that you need to know here is this one, quadratic equations. A quadratic equation is one in which one of the variables is squared. And so something like this is an example. This is just a real simple one. And if you remember a little bit of work we've done with these, when you graph these, they make a parabola. Some other ones that you might see might look something like this. They might be like 2x squared minus 3x plus 4. We've seen these earlier. We learned how to factor these and how to multiply binomials to get these. But so that's what a quadratic equation looks like. We're going to learn how to use our calculator to solve those. So the first thing we're going to do is just check out this equation. Turns out that Leonardo da Vinci kind of discovered what turned into quadratic equations when he found out about the effect of gravity, that it's a constant, and actually in an equation like this, that represents the constant pull of gravity. And a simple quadratic equation shows that an object thrown or shot up or whatever can be represented by this equation where the height is equal to the initial velocity, so how hard you throw it or how hard you shoot it, times the time, minus 16 times the time squared. And the minus is the force of gravity pulling it back down. So that's the kind of equation we're going to work with here. I'm going to skip right to an example, and we're going to do most of these in class. Let me quick show you this example here. It says use this equation to find the height of the ball after 0.5 seconds and after 2 seconds. Now if we were just doing this by hand, the function height, if we want it after 0.5 seconds, we could represent it by that, and that's going to equal 30 times 0.5 minus 16 times 0.5 squared. And if you calculate that, so we're going to take 30 times 0.5, which is 15, minus 6 times 0.5 squared is 0.25 times 16 is 4. So we really have to do 15 minus 4, which is 11. So this object will be 11 feet up after half of the second. To calculate after 2 seconds, we would find h of 2, so the function height as a function of seconds, and we would do 30 times 2 minus 16 times 2 squared. And that's equal to 60 minus 64, which is actually negative 4 feet. What that indicates to us is that the object has already hit the ground. And just to show you a couple ways you can use your calculator, or actually we're going to concentrate on graphs here. I'll show you how you can use your graph to solve this. Let me get my calculator going. So here's my equation, and I put that in. And I put the equation in. Now I need to make a graph of this. And the first thing I'm going to do is change my window. I know that after 2 seconds the object has hit the ground, so I really don't need more than 2 seconds, and I don't need negative seconds. So I'm going to let my x max be 3. And then my scale, I think I'll make that 0.2, which means every 0.2 seconds. My y min, that can be 0, because I don't really care about the height. When it was less than 0, that would be like on the ground. And then my y max, I remember that after 0.5 seconds we were up to 11, so a max of 15 might be good. So now I'm going to graph this. And there's the object flying. Now the best way to find answers on a graph like this is to press trace and then move it along. And if you watch the x value, that's the seconds. So one question asks 2 seconds, and we actually have to go below the x-axis to find that. And if we just need a quick estimate, notice right now I'm really close to 2 when my number of seconds is 1.97. So I could say that at 2 seconds we're at about a little less than -3 feet. And then I'm going to move my cursor back, and I wanted to know how high it was after 0.5 seconds. So I'm just going to keep moving until I get to 0.5. It's actually a quicker way to get to 0.5. You can just enter any of the x values, the independent variable, use the keyboard and just press 0.5 and then press enter. And after you're traced, it'll move right to that position. So we can see here at 0.5 seconds, we're at 11 feet. Okay, so that's one way you can use your calculator to solve questions about quadratic equations. I'm going to pick another problem here to do. I'm going to go to the homework, and we'll come back and do the rest of these in class. So I'm going to this page now, and I'm going to do this problem about, in physical science, a ball is launched straight upward from the ground level with an initial velocity of 50 feet per second. Its height h in feet above the ground, t seconds after it's thrown, is given by the formula. Remember that formula I just introduced to you? The coefficient of t is the velocity. So the ball is launched at a velocity of 50 feet per second. And then the pull of gravity is the other part there, the -16. So, and this equation is going to give us the height. Now it says draw a graph of this formula with time on the horizontal axis and on the vertical axis. And it says show t, which is time in seconds between 0 and 4. And then it says height between 0 and 40. So you might notice that my graph looks a little different than yours, but what you can do on your graph is just use the first quadrant and then just adjust the scale in your first quadrant. So, but I'm going to go to my calculator and draw a graph of this on the calculator. So first thing I'm going to do is change my equation. And the equation here is 50 t, we're going to use x for t, minus 16 t squared. Okay, and it told us the window to use. It said go do seconds between 0 and 4. And I'm going to make my scale a half a second now. And then it says for y, go between 0 and 40. And I think I'll make that scale 5 seconds. Now I'm going to press the graph. And just to get a couple values here, it looks like the maximum is somewhere around, remember these are 0.5 seconds, so this is 0.5, this is 1, this is 1.5. So somewhere around 1.5 seconds is the maximum. I'm just doing this to help me sketch my graph. But if I trace this and then enter 1.5 on my keypad, I'll get really close to the top. You could still move it maybe a little bit more. But it looks like the maximum is somewhere around 39 feet. And the other thing I'd like to know is, where is this point here on the x-axis? I'm going to regraph it so I can see. It looks like, so this is 1.5, 2, 2.5. Looks like a little past 3 seconds. So I'm just going to sketch my graph now. I know I go up to a maximum of about 39, and that was close to 1.5. So I'm just going to sketch my parabola. And I know that it came back and hit the x-axis a little after 3. So that's a pretty good estimate of this graph. Now let's answer some questions about this. What is the approximate value of t when the ball hits the ground? So right here. Now if we're just using this graph to find that, we would say maybe 3.1 seconds. And then it says about how high does the ball go before it starts falling. So that's the maximum. One other thing you should know about the maximum. So this is just a little piece of vocabulary you need to know. The maximum or the minimum, it's called the vertex, so the highest point. So about how high does this ball go? And we found out it's about 39 feet. After approximately how many seconds does the ball reach its maximum height? And we found that that was about 1.5. Now, If you want to be more accurate about that, we can use our calculator. And there's a couple things we can do. We can use the trace menu, and then we can go second trace. And notice there is a function here that says maximum, and that's number 4. Now to get the maximum, what you have to do is just move the cursor a little to the left of where you think the maximum is. That's what the left bound is. Press enter. Then it says right bound. You need to move it a little bit to the right of the maximum. Press enter. And then it'll guess the maximum between those two places you marked. And so if we wanted to be a little more accurate, we could say about 1.56 seconds and about 39.1 feet. 1.56 seconds, 39.1 feet, a little bit more accurate. Now remember the other question asked, what is the approximate value of t when the ball hits the ground? And that's right here. And if we want that more accurate, there's a function on your calculator for that also. And we know that's around 3, so I'm just going to press trace again and press 3 and enter so I get close to there. Now, if you go second trace again, there's a good function on your calculator for this. It's called the 0. The 0 is where the calculator touches the x-axis. So let's do that. That's number 2. And again, it'll ask me for the left bound. Left bound has to be above the x-axis, so I'm going to press enter now. Now it asks for a right bound. I need to be below the x-axis, so I need to disappear a little bit. Press enter. And then press enter one more time and it'll guess. So if I needed to be more accurate there, I could say that it'll hit the ground again at 3.125 seconds. So those are some ways you can use your graphing calculator to solve problems. And that's this lesson. I'll do the rest in class with you. See you tomorrow.